All right, hi everyone. So I was asked to do a couple of questions on the free response. So let's go ahead and take a look at question number 2. A particle is moving along the x-axis with a position at time t given by the equation x is equal to e to the negative t sine of t. Okay, and we're looking at time is between 2 pi and 0. Okay. First question is A, find the time t at which the particle is furthest to the left and justify your answer. So we are given a position function, right? So that is the position. So looking at a number line. Okay, so let's plug in some numbers first. Let's plug in 0. If I plug in 0, what does it look like? And then we could just plug in a lot of random values, but that isn't helpful at all, because when do you know when to stop? So what we do is we look at this as velocity. As I'm starting off here, if my velocity is positive, we're going to the right. If v is greater than 0, we go to the right. And if v is less than 0, we are going to the left. Okay. So how do we get from position to velocity? We take the derivative. So the derivative x prime is equal to, now careful here, that's going to be chain rule. No, sorry, product rule. So we're going to have to do product rule here, right? So the derivative of the front is e to the negative t, and the derivative chain rule of negative t is going to be negative 1. And then leave the back alone. Plus derivative of the back is cosine t, leave the front alone. Okay, that is our chain rule. And if we want, we can simplify that if we want. We can say it's e to the negative t, and then we have negative sine of t plus cosine of t. Okay. Now, our goal is to now say, okay, fine, we get it, positive and negative. But how do I find when it changes? We make that equal to 0. Now, a couple things we want to say is, do any of these parts go to 0? Does e to the negative t ever go to 0? No, even at infinity. And we're just stopping at 2 pi. E to the negative t looks like a graph that looks like that. Sorry, like this. So if it goes to 0, it has to go to 0 here. Now, at what point does sine and cosine cancel each other out? Right? One is positive, one is negative. So if you remember your unit circle real quick, that's actually at 1, 1, right? That's at 45 degrees, pi over 4. And over here on the left side at 5 pi over 4, because that's negative 1, negative 1. Okay. So if I take the sine of pi over 4, that's going to give us 1. So negative 1 plus the cosine of pi over 4. Oh, sorry, it's not 1. It's going to be 1 over square root of 2. 1 over square root of 2, right? Square root of 2. Opposite over hypotenuse. So it's going to be 1 over square root of 2 plus 1 over square root of 2. And you can see these end up canceling out. So not only does it happen in quadrant 1, but it also happens in quadrant 3. And 1 and 3 are both within 2 pi. So I'm going to draw my little number line here, just so you guys can see this. And if I'm telling you 1, 0 is at pi over 4, and the other one is 5 pi over 4. These are when the slope is 0. What happens in between these values? What happens in between these values? So if I plug in something over here, between 0, what happens to the velocity? Is that positive or negative? Well, if you look here, e to the negative t, that will always be positive, so we're not worried about that. And what happens between, oh darn it, give me a second. Okay, so we could plug in values. If I plug in values that are, let's see. So in quadrant 1 here, before we hit this point here, which is bigger, our sine or cosine values? Our sine or cosine values? Our cosine values are going to be bigger than our sine values, right? So this is going to be, I would say, I'll say this would be positive. Over here, from here to here, if I plug in pi over 2, what would that be? So sine of pi over 2 is 0, but the cosine, no, sine of pi over 2 is 1, but the cosine is 0, so it's going to be negative. And then over here past it, 3 pi over 2, the sign is negative, negative is a positive, cosine is 0, so we're looking at a positive number. Okay. So when are we furthest left? Now, if you look at this, the idea here, if I'm starting from 0, whatever this position is, and then I move to the right, stop, then I move to the left a lot, and then I'm going to move to the right again, okay? So you're thinking probably it's going to be the most left, maybe here. That's what I'm thinking already. Because we started going to the right, this portion here is this whole section here. I'm moving to the left a lot. Okay. Now, how do we eventually find out? So we can also just plug it in. Plug in at 0, plug in at all these points here. What are the actual values of my function? So x of t is equal to e to the negative t sine of t. Now you might think this is going to be hard to plug in, but it's actually not, because 0, pi over 4, sine of 5 pi over 4, and 2 pi are not hard to do with sine. So x of t is equal to let's do 0 first, e to the 0 power, sine of 0. What's sine of 0? 0, we're at 0. X of pi over 4, e to the pi over 4 is some number, okay? Some very small number. Oh, actually, it's a negative, right? Some very small number. And then we're going to say sine of pi over 4. If you remember unit circle, sine is 1 square root of 2. That's going to be some number that's positive. So this is positive, but small. And then we're not allowed to calculate on this problem. Next one, x of 5 pi over 4. E to the negative 5 pi over 4. That's going to be a very small number. What is the sine of 5 pi over 4 though? Okay, that's actually a negative number, so this is negative. So the position here is the only negative so far. We've had 0, positive, and let's look at our last point, x of 2 pi, e of negative 2 pi, sine of 2 pi. That's going to be 0. We're back to 0. So looking at our positions, we either get a choice of 0 being my most left number, a positive to the right, or a negative. So this is actually our only option here. Okay, this is furthest to the left. It's my only negative value. Okay. Now, anyone have a question about that? So what I did is I did a couple of things. First, we had to figure out when are you headed toward the left, and you're headed toward the left when your velocity is negative. So take the derivative. And how do I know when it's going to be negative? I don't know. I'm going to actually look for the zeros first. That's always the easiest way. And then you can do a sign chart if you want to say, hey, this part goes to the right, then it goes to the left, and then goes back to the right. So it's probably either going to be here or here. And then if you want, you can also just plug all 4 in when you're comparing. It's just like when you find absolute maximum minimums, you want to compare all your critical points as well as the endpoints. Okay, part B, find the value of a constant A for which x of t satisfies this equation. And it's constant x double prime t plus x prime t plus x of t is equal to 0. Okay, so we're looking for the value a. So what would a have to be? Well, can I find all these other ones? Sure, right? We already found what x of t is. X of t is given by e to the t, negative t, sine of x. Oh, sine of t, I'm sorry, sine of t. The derivative we already wrote as e of negative t, negative sine of x, oh, sorry, t, sorry, plus cosine of t. I shouldn't fix those. And if I want to take the derivative again, we can. And then this part here, what's the derivative of our derivative? that's going to be a little bit of work for us, but we can take the derivative. I can just take the product rule of this. It's e negative t negative, and then negative sine of t plus cosine of t, plus the derivative of the inside, which is going to be negative cosine of t minus sine of t. Leave the front alone. And stick a in front of that. So unfortunately, it's going to be this super long problem like that, right? It's all this in front plus the other two derivatives. Now, how do we make this go zero? Okay, well, let's see. We have some like terms, I would say. We all have e to the t. We can take that out. And then we all have e to the t. Let me show you guys. We have e to the t here, e to t, e to the t, e to negative t, right? Let's take all those out. I'll make the problem a little bit easier to look at. Actually, oh, here's something. Oh, wait, no. I can simplify some of let me simplify these two right here. So this can be combined. Wait, can it be combined? I think. Derivative of, no, this is going to be, so e to the, okay, yeah, we can combine these. Looks like we can combine them. So this is negative t negative sine of t plus cosine of t plus e to the t negative cosine t minus sine of t. I'm going to pull out the e to the t, e to the negative t. And we're left with sine of t minus cosine of t plus, nope, not plus, minus cosine of t minus sine of t. Gives me e to negative t. These guys become negative 2 cosine t. And then the sine and sine, see how they're different signs? They cancel out. Sorry, sine minus sine. So we're left with this, a. So rewriting it, it's a e to the negative t minus 2 cosine of t plus everything else, e to the negative t, negative sine of t plus cosine of t plus e to the negative t, sine of t. Okay, this is all like algebra 2. If we factor out the e to the t, what else could we do? Factor out e to the t, e to the negative t. We're left with negative 2a cosine of t plus, nope, minus sine of t cosine of t plus sine of t. The sines cancel out. Now we're left with e to the negative t, 2a cosine of t minus, sorry, plus cosine of t. We can factor out the cosine, e to the negative t, cosine of t, left over 2a plus 1. Oops, I lost my negative. Okay. And we can say, when does negative 2a plus 1 equals to 0? That is when a is equal to 1/2. Okay. So a couple things about this I want to say that are reassuring is that look at how they gave you the points for this. You're supposed to do this question in like 15 minutes, right? And we spent a little more than 15 minutes here. I'm kind of wandering around. But if you look at the point distribution, that's the part I want you guys to pay attention to. You got 2 points here for just taking the derivative. That's great. I'll take 2 points. You get another point for just writing equal to 0. Even if you didn't get the rest of the other two, hey, you got 3 points. That's pretty good. Over here, you got 2 points for taking that second derivative. If you got this second derivative here, I think this is where my second derivative was. Yeah, this over here, this is my second derivative, okay? This part right here. If you did that, you got points for that. You got 2 points already. And then if you plug them all in, writing this crazy long line, you got another point. So the only parts, if you messed up along the way, you would have lost 1, 2, and 3 points out of 9. 3 out of 9 is pretty good for a question that took a lot of time to do. So that's why I wanted you guys to see that even if you write something, of course, it has to be relative, it has to make sense. You can still get a lot of points. If you had no clue how to start this and you thought, hey, okay, left and right, oh, that could be velocity, and you took the derivative, you could have got a point for that. So you can start getting some points back. Okay. And that's always like the thing. You might not be able to get all the points, fine. Maybe you're a little confused, but if you can get at least on the right path, you can get some points back.
Hey, Mr. Ko.
Okay, the graph of the function f is shown above to have two consistent lines, 2 line segments. Let g be the given function, and that's just the integral between 0 to x. Now, all these types of questions that look like this, they are kind of annoying because it's not, they show you from negative to 2. So if I draw the picture, negative 2 comma negative 3, and 2 comma negative 3, they give you from negative 2 to 2. But if you look at the integral, they always start off kind of like not even as negative 2, they start off at 0. Okay, they start off right at 0. So it's going to be from here going forward or here going backwards. So let's be aware of that. So the first question is, find the integral, find A is find g of negative 1. Fine, what's g of negative 1? Means we're just going to plug in our negative 1. What's the integral between 0 and negative 1 of f of t dt? Now, please be advised that we always read from left to right. That's just how we've been taught in this country, reading from left to right. So is this 0 to negative 1 left to right? It's not. So I'm going to spin it around and throw a negative sign in the front. So what's the integral of f of x, or f, sorry, in this case, f of t dt? What is the integral between negative 1 here all the way to 0? Hopefully you see that's just a triangle of half base times height. The integral of half base times height. And then so the integral would be a triangle of half of 1 times the height of 3. And that's going to be 3 over 2. Okay, but remember the negative sign in the front? That's going to be negative 3 over 2. They're asking you, what is next part? What is the derivative? What's g prime at negative 1? So we take the derivative. What is the derivative of the function? And then we're gonna, after we take the derivative, we're gonna plug it in. So the derivative of an integral, remember that's just plugging in fundamental theorem of calculus, that's f of x. And then we're gonna plug in our negative 1. What is the value function at negative 1? Hopefully you can see on the graph. At negative 1, the value function is 0. Okay. What's the second derivative? Fine, now that we know that the function is f of x, what's the second derivative at -1? Well, that would be the, whoops, I should put it this way. d over dx of f of x, that's f prime. What's f prime at -1? Okay, what is the slope? The slope is 1, 2, 3 over 1. The slope is 3. Question 1 is pretty easy. As you can see, they gave you 1 point per each of these parts. Okay, let's look at B. For what values of x on the open interval between -2 and 2 is g increasing? Explain your function. Oh, explain your reasoning. Now, let's be careful again because g doesn't start all the way from -2. If we said that we're looking at from -2, that might be a little easier. But let's just look at the function. It's the g of x is equal to the integral from 0 to x of f of t dt. Now, how do we tell something is increasing? The keyword is there is increasing. We know something is increasing when the derivative is positive, okay? The derivative is positive. So take the derivative. G prime of x is the derivative of this function. Now you tell me what happens when we take the derivative of the integral. Hopefully it's not that hard, right? You just plug it in. This is just f of x. That's our derivative. How do we know it's increasing? Well, when does the function look like it's greater than 0? So hopefully you see that in this graph, -1 and 1, it's increasing between -1 and 1 because the derivative is positive. And f is my derivative, so guess what? That's the only part of f that's positive. That's the only part of f that's positive. Okay. Let's look at the second part. So f is increasing. G is increasing between -1 and 1, okay? Between -1 and 1 because g of prime of x is greater than 0. Okay? Okay, next part is for what values of x in the open interval between -2 and 2 is the graph concave down? Now, how to get to concavity? Now, be careful again. Remember, they're working on g. So to get to the concavity of g, we take 2 derivatives down. So we're looking for g double prime. So that's going to be f, the derivative of f, which is f prime. Okay. Now, when is f prime negative? So when do you have the slope? Looking back at this graph here, looking back at our original graph, when is f's derivative, when is f slope negative? Well, is it negative on the left side or is it negative on the right side? Hopefully you see it's negative on the right side. So this happens between 0 and 2. Because g double prime, which is our f prime, is less than 0. Right? It's all about looking at these pictures. The last question on the axis provided, sketch the graph of g on the closed interval of -2 to 2. So they're supposed to give you an axis. So let's say they give you this axis here. So how do you graph g? And remember, g is the integral between 0 and x of f of x. Okay. So I would like to ask you this question. Let's plug in 0. What's the integral from 0 to 0? Is that a hard question, hard, easy question? What happens? What's the integral from 0 to 0? Would you be okay if the integral of 0, 0 is just 0? That's a 0. Now, as the graph started growing, so we have some points that we want to pay attention to. As the graph started growing, we're going to start adding up this area underneath this curve. So are we adding value or losing value? Would you guys be okay? I'm actually adding value. We stop adding value and we start subtracting value. We start subtracting value. What happens on the left side? If the left side confuses you, you can rewrite it as, right, from x to 0, negative of f of x. And this is for when x is less than 0. So you could say, isn't this a positive value? But because of this negative sign, it turns out this is actually a negative value. It actually goes the other way around. Okay. Let me show you again. If I go from -1 to 0, what's the area of -1 to 0? Isn't that all positive? But because I reverse the order, we stick a negative sign on it. That's why it's going to be a negative area. Okay. All right. Okay, the last one we're working on question number 4. Hopefully we can get that out before our time is up today. Okay, question number 4. FB is, let R be the shaded region bound by the graph y is equal to the square root of x, y is equal to e to the negative 3x, and the vertical line x is equal to 1. And nicely for us, they gave us the graph already, which is great. And call that 1, okay? So find the area of R. Here is R. Now, with the way I teach area, I always say that, hey, just draw a line up to bottom. We're taking upper minus lower. So we have our two equations. It's going to be the integral of upper, which is the square root of x, minus the lower, which is e to the negative 3x dx. Now, the problem is we do not know where this value is. Okay, we know it stops at 1. So we go from our, what do we know, to 1. Now, this is a calculator problem. And looking here, if you graph this on your calculator, this tells you this is 0.238734. Now, how do you do this on your graphing calculator? Remember, you can use graph it and then hit second calculate trace and then intersect. And that'll give you your 0.28734. Okay, now that we have that number, perfect. That's, the rest is just calculator work. Okay, and that you should get the answer 0.442. Easy peasy. The second part is find the volume of the solid generated when R is revolved around the horizontal line y is equal to 1. So y is equal to 1 is right on top here. And we're going to revolve it this way. Would that give you a washer or a disc if I'm rotating it up? Okay, the one, let's rotate it along the horizontal line y is equal to 1. Hopefully you're going to tell me a washer. And our washer equation is integral of capital R squared minus little r squared dx between, and at this point, it's going to be negative 2.38 to 1. Now, you could write it out. You could write, it's going to be, this is going to be integral from negative 2.38 to 1 of e to the negative 3x. Oh, sorry, the radius goes from, here's my radius, right? Axis of rotation over. So that's going to be 1 minus squared minus 1 to my second radius, 1 minus the square root of x squared dx. And that's just calculator work. Okay, outer minus inner. Okay, the last one is the region R is the base of a solid. With a solid, each cross section is a perpendicular to the x axis with a rectangle whose 5 times the length of its base. Okay, so we're going to draw rectangles coming out of here. Right, and the rectangles are going to come like that, coming straight out. And the height is 5s. Let's call it s here, 5s. So we're going to add up rectangles, 5s squared, right? Because 5 times s is s squared. And we're going to add up all these slides between 0.238 to 1. dx. Now what's s? S is this upper minus lower, okay? S is upper minus lower, which means s is equal to the square root of x minus e to negative 3x. That's our s value. You plug it in and we're golden, negative 238, 0.238 to 1 of square root of x minus e to negative 3x times 5 squared dx. Now, I can save you like 20 seconds. Since I wrote this as s, I do not need to rewrite this equation. The readers understand that when you call something s, you know that's s, and you can just type that in the calculator already. Okay. All right, that's it. Okay, so 5a, the temperature in degrees Celsius of the water in a pond is differentiable function w of time t. Okay, so w of time t, that's looking on the right here on my table. So it's differentiable, that means we know it's continuous and all the derivatives exist. Okay. Now the table above shows the water temperature as recorded between every 3 days over a 15-day period. Okay, every 3 days over 15 days, got it. So that's the water temperature. Use the data on the table to find the approximate. What is W12? Show the computation lead to your answer. Okay, what does W prime mean? That's a way of saying slope. Now there's a lot of different ways. Like if you look here on the left side, they'll take any of those answers. But the way I'm going to approximate at 12 is I'm just going to say, hey, look at my table between, sorry, T, I was right, X, right, T, and WT. So this is another way of saying slope. And they use the word big deal as approximate. They don't want you to actually know what that is. So we're going to use the values right next to 12. Here is 9, 15, 24, 22, and 21. And we're going to say we're going to use these values to approximate the slope at 12. So 21 minus 24 over 15 minus 9, that gives us negative 3 over 6, which is negative 1/2. And that's one of my answers here on my left. And as long as we have the units, it's degrees Celsius over days, right? Okay, so that's how they want us to approximate. An approximation is just using our f of b minus f of a to find the slope. And if you look at it, they actually give you 3 possibilities. They don't care if you use these two, or overall. Okay, all those are approximations of what the slope could be there. And that's it.